For problem 2 part A, we see the graph of VO1 and VO2. And because VO2 gets value from VO1, it doesn't really get any voltage change until the gate closes. So we see that until from 5.5 to 9.5, or until 9.5 milliseconds, we see that VO2 is actually value of 0 volts. And for the second question, we see that we have to observe or record the voltage change, or VO2, from 9.5 to 13.5. And from the first graph, we see that every interval of time seconds, so 1 to 2, 3 to 4, 5 to 6, you see that it's 10 volts. And using our integral equation for the op-amp, we see that from 9.5 to 10, we add the voltage changes from 9.5 to 10, 11 to 12, and 13 to 13.5 in order to see the total change of the VO2, and we get negative 1 over 5 just from the graph itself, because the equation says it's negative 1 over RC, integral of the time, and then the integral. So it's basically integral of the time that's from Vn, which is VO1. So we get these two equations, plug it in, and get negative 5. And we see that the way we obtained the graph was from 9.5 to 5, we get the slope of, it's kind of hard to see, negative 0.1. And using that, since the interval of time is only about half milliseconds, we see that the total change of y value, VO2, is negative 1 over 20 volts. And using that logic, we got this graph total.